guys. So here we are to another funny question. Question number three. A bit lengthy description again, and this question is about returning the correct throne inheritance order. Okay, so imagine you are a king and you have kids, and your children have grandchildren. You want to provide implementation that delivers the correct order of inheritance, and it takes into account also not only births but also deaths. So this is what we are being asked. So we need to implement a birth function, death function, and the get inheritance order method. Okay, method. We are talking about methods. So we have a few examples here. Okay, like in here we are telling that Andy has birth and is son of king, and the same for Bob and Catherine. Both are sons of children of the king. Then Andy, which is king, children of king, has a children called Matthew, and so forth. Okay, we have another examples, I think, and that's about it. Okay. So we can look at this problem as or my approach to this problem was to solve it with backtracking. Okay, not backtracking, sorry, excuse me for that, but DFS. And it is as simple as building the family tree of the each entry. Okay, we can sort of think of this as a graph. So the king has three children, which is Logan, Osea, and Rhonda. And Logan has no children. Osea has two children herself, and this is kind of the tree. Okay. It is quite easy to visualize this solution. Okay, so to have the right order, which they explain how it works, we have first the king, then the first children that has given birth will have the succession. Okay, if this guy dies, then we get this one, okay, as successor. If this guy dies, we get this one. Okay, if this guy dies, his daughter Betty will take succession. If she dies, we go to Carl. Okay, so we go to Carl. If he dies, we go to Ellen. If Ellen dies, okay, you understand what I mean. So this is a depth first search exercise, plain and simple, that you can do. So that's a basic solution. Okay, that's a very basic solution. Probably there is a better solution, and I tried for quite some time a better solution, but I failed. Okay, it was a concept with linked list, so that I could retrieve, so that I could do all the operations in constant time. But it was not possible. I was not able to accomplish that implementation, so I come up with this very basic solution using depth first search to find the correct order. So yeah, as I told you, I made kind of a graph with this. Okay, and the key is a string that will have the name of the people, the candidates for the throne, and I have a list here of candidates, and this list, well, I actually use an object that I call candidate. I use the object that I called candidate. It has a flag is dead, or no, I use the flag is alive, and I have a list with children. Okay, so this is actually what I did. So I start with the king. If the king is dead, it doesn't go to the list. So I go to Logan. If he's dead, doesn't go to the list, and so forth. And then in this situation, as all the parents are all the ancestors are dead, Luella is the first to be added, and she is the successor. And then would come Herman, and then Rhonda, and so forth. Okay. So looking at the code is pretty simple. Okay. So as I told you, I have this object here. So this is an old version of the code, so the names are not updated, but this pair here contains the flag is alive. Okay, this flag is alive to know that the candidate is alive, and we have a children. Is children, the children of the person. Yeah. So we also have a string here to tell us who is the king, so that we can initiate our get inheritance order. We start always with the king, whether or not the king is alive, and this is our basis. We use an hash map to store the candidates in this format, string for the name, and we use the object that I call pair in this version, but it's a candidate, and it has is alive that refers to the king. Okay, the king is alive and has these children. So that's it. Yeah. So when someone gives to birth, we go to the parent, and we add to as children these children, the children name, and we also add to the map the new children. Okay, we also add to the map the new children. so that we always have the things consistent. Then when somebody dies, we just get that person and we set is alive to false. Okay, and when we want to get the inheritance, is very simple. Is a recursive um, is a recursive recursive method, and I start with the king, and if and I pass also the list that will hold the answer, and I get the node that starts with the string word. If he's alive, we add to the list of answer. If it's not alive, we don't add, and then we go check the children, and we check the same for the children. Okay, so the base case. No, it's not about base case. So that's it, guys. To get the inheritance order, we start searching in the king, okay, and then if he's alive, we add to the answer. If he's not alive, we don't add, and then we inspect the children in order, and we will check for each children if they are alive, and then the children's and so forth. Okay, typical depth first search exercise. Okay, I didn't perform spectacularly, but it doesn't really matter. Okay, this is 100%, but I bet there are better solutions out there. The stats are not updated so far, so that's about it.